We will be adding rational expressions, but first we will start with those that are similar or with the same denominators. Okay, so same with fractions in our elementary days. If you have fractions or adding fractions with the same denominators, we copy the denominator and then add the numerator. So 5 plus 7. In adding 5 and 7, we will have 12. Then copy 3x. Now, if you are asked to simplify your final answer, 12 and 3 can be divided both by 3. So if you divide 12 by 3, that will be 4. And 3 divided by 3, that will be 1, or simply cancelled out. So for your final answer, you are left with 4 in the numerator and x in the denominator. So this will be your final answer. For example number 2, again, we have similar rational algebraic expressions because we have the same denominators. So we copy x plus y and then add the numerators. So we have 2x plus 2y. Again, if you are to simplify your final answer, we have to apply factoring method in the numerator because it can be factored out. So we will use CMF here. So applying CMF, we can look for, or we can have a common factor of 2 because 2 is, or 2 can divide 2x and 2y. Okay, if we divide 2x by the common factor 2, this will be cancelled out, so you are left with x. So you put x here, then plus, because you have plus there. 2y divided by the common factor, which is 2, cancelled out, you are left with y. So you put y here. And then, copy the denominator x plus y. So, we can only cancel out binomials like this if we put pairs of parentheses also in the denominator. So, here we can cancel out x plus y. So, you are left with 2 in the numerator, and since nothing is left here in the denominator, you put 1. For your final answer, 2 divided by 2 is 2. So, that will be your final answer. Now, what if we have different denominators? What do we call them? Okay, we call them dissimilar. So let us now add dissimilar rational algebraic expressions, or those with different denominators. Okay, so let us have this example. If I have x over x minus 2, so we have here x, plus x plus 1 all over x plus 3. So what we're going to do here is to get the LCD. But since you have two binomials and they are not factorable, we just copy each denominator. Okay, so this will be our LCD directly. So same with adding the similar fractions, we divide the LCD by the denominator and then multiply it by the numerator. So if that's the case, we will have the LCD x minus 2 times x plus 3. We will divide it by the first denominator, and then the answer will be multiplied by the numerator, which is x. So what we're going to do here is to cancel out this one because they are the same. So you're left with x plus 3. Multiply it by x. So in multiplying binomial by a monomial, we distribute the monomial by multiplying it to each term in the binomial. So x multiplied by x, you add the exponent, so that will be x squared. Then plus x multiplied by 3, that will be 3x. So this will be written here. So we have here x squared plus 3x. So this will be your numerator for the first fraction. Then you put plus because we have there plus. For the second fraction, same process will be done. The LCD will be divided by the denominator, so that will be x minus 2 multiplied by x plus 3, your LCD, divided by the denominator x plus 3. Then the answer here will be multiplied by the numerator x plus 1. Okay, so canceling out the same term in the numerator and in the denominator, you are left with x minus 2. Then multiply it by x plus 1. Okay, so in multiplying binomial to a binomial, we apply the smiling method or FOIL method. So smiling method goes like this. So multiply x and x, we have x squared. Multiply negative 2 and 1, we have negative 2. Negative 2 multiplied by x is negative 2x. Then x multiplied by 1, or any term multiplied by 1 is the term itself. So in this part, we try to add them. But since you have here 1, and they are different in signs, we have to subtract them. So 2 minus 1, that will be 1. Then copy x. But since your number here, or the bigger number is negative, we put negative. So for your final answer here, we have x squared minus, you just simply disregard this. So x squared minus x minus 2. So this will be written here. X squared minus x minus 2. So as you can see, we can still simplify the numerator because we are to add like terms. So which are the like terms here? Those with the same variable and exponent are like terms. So we have here x squared and another x squared here, so we can add them. So since you have here 1 and 1 also here, if you add the 2, that will be 2x squared. So let me join first the common terms, or we have here x squared plus x squared. So that will be for this pair. Then plus 3x and minus x here are like terms because they have x to the first power. So if I put positive 3x or 3x, then minus x. Then plus, for the constant, I only have a constant here and no constant here, so I put minus 2 here. Then all over x minus 2, then x plus 3. Now, let us finalize this part. So again, I have 1 here and another 1 here. So you will add the numerical coefficients and then copy x squared. So you will have here 2, then copy x squared. On this part, I have here 1. So 3 minus 1, that will be 2. So plus 2, then copy x. And then on this part, to simplify the signs, positive times negative, that will be negative. So minus 2. All over x minus 2, then x plus 3. Now, as you can see, you can find a common factor to each term, which is 2. So you try to simplify. If there are terms in the numerator and in the denominator that can be eliminated, then you can still simplify the whole term. So here, let's try. If we factor this out by CMF, 2 is common to each term. So if I divide 2x squared by 2, 2 will be cancelled out, so you will be left with x squared. Now, if I have 2x divided by 2, that 2 2 will be cancelled out. I will be left with x. Then minus 2 divided by 2 is 1. All over x minus 2, then x plus 3. So try to factor out this term. Since your last term, you have a trinomial, so you are left with GT or PST. But since your last term is negative, you try to use GT. In finding factors of this polynomial using GT, we look for factors of negative 1 that when added, you can have positive 1. So let's try. What are the factors of negative 1? The factors of negative 1 can be positive 1 and negative 1. So if you add these two, you will come up with 0. But since your middle term here is positive 1, it means that you cannot factor out this polynomial. So if this is not factorable, therefore you cannot have any common term here. So if there are no common terms in the numerator and in the denominator, nothing can be eliminated. Therefore, this is the time that you will decide that this is your final answer. Okay, now let us try another example like this. If I have x over x squared minus 4 added by 1 over x plus 2. So in this part, the first denominator is factorable. So we have to factor out this one to get the LCD. So x minus 4, if we factor this out, we use dots. Okay, difference of two squares. Applying dots, we have plus and minus. Square root of x squared, we have x. Square root of 4 is 2. For your second denominator, it is not factorable, so you just simply write x plus 2. So for your LCD, so you look for common factors. So we have here there x plus 2, so you put x plus 2 here, and the factor that is not common to both, so you put here x minus 2. So this will be your LCD. So you have x plus 2, then x minus 2. So remember this part, huh? Okay. What am I going to put here is this. I have to divide this by the denominator, then multiply it by the numerator. So if that's the case, let's start with the first one. So here, x plus 2 and x minus 2 for the LCD divided by it here. So in here, instead of writing x squared minus 4, you put these two, the factors. X plus 2, x minus 2. Then the answer will be multiplied by the numerator, x. So cancelling out common terms. So nothing is left here. Instead, nothing is left here, but you will write 1, then multiply it by x. So your answer here is x. So your x will be written here. So this will be for the first numerator. Then plus. For the second numerator, again, you will divide the LCD by the denominator. So your LCD is x plus 2, x minus 2. Then your denominator, x plus 2. Then look at here. Your factor for here is still x plus 2. Then the answer will be multiplied by the numerator, which is 1. So cancelling common terms, you are left with x minus 2. Multiply it by 1. So any term multiplied by 1 is the term itself. So x minus 2. So you will write x minus 2 here. Okay. Now, so let me erase this part. Let us now simplify or solve the numerator. So, combining like terms, x and x are like terms. So, we put x, positive x, then positive x, so plus x, then plus the constant. So, the constant is only present here, no constant here. So, you just simply write it there. Then, copy the denominator, x plus 2, then x minus 2. Then since you have here 1 and another 1 here, so you will add those numerical coefficients. So that will be 2, then copy x, then simplify this one, positive times negative, that will be negative. Then x plus 2, then x minus 2. Now, your numerator is still factorable. So try to simplify. So what am I going to use here is CMF because I can see a common factor to both terms. So the common factor is, so let us try to simplify everything here. So the common factor here is 2. Then if I divide 2x by 2, 2 will be cancelled out. You will be left with x. Then minus 2 divided by 2, that is 1. All over the LCD, x plus 2, then x minus 2. I'm sorry. So, just check if there are common terms. So, your 2 here cannot be eliminated with 2 here because 2 is combined with x and the operation addition. So, this is a binomial, this is a monomial, so you cannot cancel out 2 and 2 here. So, look at the ones in the parentheses. I have here x minus 1, x plus 2, x minus 2. So, there are no common terms in the numerator and in the denominator. So, nothing can be eliminated when you apply the factoring method here. Therefore, your final answer is this one.